I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, December 6th. Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype. Looking at significant wave heights in the North Pacific Ocean, we have a bit of a gale, actually a storm in the northwestern Gulf of Alaska, producing 48-foot seas aimed to the east and northeast, and this is actually the tail end of the system. It was stronger a day or two ago when it was pushing through the western Gulf. Swell is in the water, heading our way again. As usual, we'll start looking at jet stream level winds. These winds of about 30,000 feet help support the formation of gales, and when they form, help direct their track. We're looking for a trough, a dip in the jet, just like that right there. And what that does is help support a counterclockwise flow aloft up in the atmosphere, then also down at the ocean surface. And if that circulation is strong enough, that's called low pressure, it generates winds. And if the winds are strong enough, they generate seas. If the seas are high enough, they turn into swell as they radiate away from the fetch area, and swell, when it hits your beach, of course, turns into surf. Alright, so we have a consolidated flow pushing the whole way across the Pacific, starting down at as low as 32 south, but generally about on the 35 south, north line, 35 north, and then ridging a little bit to the north as it approaches the U.S. West Coast. This is a great pattern. This is typically what you want to see, the kind of jet stream pattern that supports storm development. All right, let's put this into motion. As we get into Monday, the trough continues, but you see winds starting to fade in the apex, the lowest part of the trough here. And as we get further into Monday, the trough basically fades out, but the jet's still pretty consolidated. And with winds building to 180 knots off Japan, quickly you notice another trough starting to build Tuesday night, approaching call it the North Dateline region right there. Small circulation is possible. 190 knot winds, that's doing pretty well. And as we get into Wednesday, that builds, supporting gale development again. That trough continues over the dateline into the northwestern Gulf of Alaska on Thursday, but you notice winds starting to fade out here, and the trough and support for gale development likely to fade as well. We get into Saturday, though, all hope is not lost. The jet is still consolidated, pretty solid. Notice, actually, let's go back here just a little bit. Notice a bit of the jet trying to ridge or trying to push south, but it's all inland, likely not supporting any precipitation potential for California. Anyway, we get into later Saturday, and then into Sunday, we see winds starting to build just a little bit in the Gulf of Alaska there. That should support gale development, and also winds building off Japan again, offering some hope. We're out 180 hours. Looks like a gale could be possible in the Gulf of Alaska Sunday night, and potentially something off Japan long term. Of course, it's 180 hours out. We never believe a model that far into the future. Next up, we're checking surface level pressure and surface level winds. The effect, we're trying to monitor the effect of what the jet stream is doing in the upper atmosphere, if it's having an effect down at the surface. And clearly it is. There's a big broad trough here, and associating with that, a big, broad, low-pressure system, a gale with 45 knot winds in the northern Gulf of Alaska, pressure down to 954 millibars, roughly. And that's pretty deep low, but it is fading. This system was much stronger a day ago, Saturday, when it was in the western Gulf of Alaska. It had confirmed winds at 60 to 65 knots. That's hurricane force, but much larger than a hurricane, and having the likely effect of much larger seas on the ocean surface. All right, so Sunday, the gale fades out as we get into Monday. No big surprise there. Kind of a nondescript jet surface pressure pattern sets up. Weak high pressure off the U.S. West Coast, but low pressure starts developing over the North Dateline region, a gale with up to 40 knot winds right there as we get into Wednesday morning. Continuing through the day Wednesday, almost a little hint of 45-knot winds Thursday, and continuing, approaching the dateline, but not quite making it, certainly enough to generate some seas. Also notice another little gale trying to develop in the Gulf of Alaska on Thursday night into Friday. There we go. 45-knot winds, a complex gale. That's what they call it. So when you have two gales in close proximity to each other and all sort of sharing the same space, you can have, I've seen up to as many as 3 separate individual gale systems sort of orbiting around each other, if you will. Anyway, Friday, 45-knot winds in the Gulf of Alaska, fading to 40 knots, and then rebuilding to 45 knots on Saturday. Certainly that's good for swell development. And then another system, 150 hours out on Sunday, building, approaching the dateline. Here we are at 180 hours, 55, looks like almost 60-knot winds, aimed reasonably well at Hawaii. And yet another system is projected behind that, building over Japan. A very interesting pattern we're in now, considering that it's La Nina, the no MJO activity, and we had been suggesting that something like this probably wouldn't happen this year, but now it is. And we have some theories as to why that might be. All right. Wave heights, the effect of the wind on the ocean surface. But we're back in time. We're back last week, Sunday, a week ago. This was storm number 1, the first significant class storm of the 2020-21 winter season. Max significant wave heights, 57.7 feet. This was the peak of this system. Notice it's west of the dateline. Pushes over the dateline, or it pushed over the dateline on Sunday into Monday. Seas 48 feet. And then pretty much dissipated right at about the 160 west mark, just about north of Hawaii, and was gone. Okay? And then let's see, we're going out now, just sort of reviewing what happened the rest of last week. Couple of small systems, nothing of any particular interest until we got into Friday night. Then here comes our new storm. Now notice, the last system, storm number 1, faded right at 160. This was just getting warmed up at 178 west, building to 50-foot seas Friday night, and then 52.8-foot seas on Saturday morning, right at about where the other storm died. The point being, this is a lot closer to the U.S. West Coast, but also a lot due north of Hawaii, meaning less sideband energy radiating down to the islands. The main target for this one will probably be in this area here, let's say Point Conception northward. The Southern California exposed break should see something from it. Anyway, we get into Saturday night. The system lifted north and then started to fade. Looking forward now, we're into this evening. Our storm number 2 fading out completely and gone. You can, in fact, let's go back. You can literally see, this isn't even swell period. This is just sea heights, raw sea heights impacting Hawaii on Sunday. Not so large size. You can see the front, we'll call it a swell front, approaching the U.S. West Coast on Monday into Tuesday and impacting it. Just raw seas alone, 18 feet. And that doesn't, there's some bump and rawness in there. Swell is underneath that. All right, anyway, so we're into Tuesday. Now we know there's another system supposed to develop over the North Dateline region. It does on Wednesday into Thursday, 26, maybe 27. Oh, there we go, 28, 30-foot seas for a second there. And then another system is forecast on Friday. While this one fades, the other one of the complex pair develops on Friday, building 28, 32, maybe 34, we'll say 32-foot seas there. Certainly generating more swell radiating to the U.S. West Coast. And then 180 hours out, here comes our new storm there, and yet another system off Japan. Again, a week out, don't believe the models, but it does offer hope. It's better than the doom and gloom we were looking at back in September and October. And then with storm number 2, we got a satellite pass. The Jason 3 satellite right here passed over the eastern quadrant of this storm at roughly 6E Saturday. That'd be Friday night. The exact details are down here. Okay, and we'll get into that in a second. But you see the satellite pass, it's a very thin pass. It doesn't cover a broad swath of ocean. The actual width is way less than this. It's probably the thickness of one of those red lines. But what we're trying to do is show all the readings from the satellite along this track so you can look at the colors and compare it to the wave model to see how accurate the wave model is. Remember, the model is just a theoretical projection based on some input and a bunch of other stuff, but this is hard data. The satellite actually beaming radar off the ocean surface, capturing the return, measuring the difference in return time to calculate a wave height, and can do it amazingly accurate. All right, so you can see the biggest activity is right here in the eastern quadrant. 15 reading average, 15 individual measurements, 48.7 foot seas. That would be right here at 40.2, 160, we'll call it 168 west, so that would be right about there. And what did we say, 40.2? Which is right there. So right barely on the leading edge of where the max seas are, with a individual reading there, one reading, the peak reading there at 53.7 feet. The wave model suggested wave heights were, we'll say, roughly 47, maybe 48 feet right in this region, and the average was 48.7. So the model is spot on. That is good news. That means for sure there is some sort of significant class swell in the water pushing our way. Next up, wind. Wind forecast. Sunday, north winds, 15 knots along the California coast. It was less in the morning, but certainly by even midday, it was getting pretty bumped up at exposed breaks. Trades for the Hawaiian Islands, light southeast, 10, maybe 15 knots. That's about pretty close to what we were able to verify. Monday, north winds continue along the California coast, 15, maybe 10 knots near shore, but 15, 20 knots offshore, creating some bump. Trades for Hawaii, again, light east-southeast. And then we get into the important Tuesday time frame along the California coast. Now, winds off the coast, 15, 20 knots from the north, but near shore, high-res models suggesting northeast in the 5 to 10 knot range. Might be a little bit too much for big wave spots. More protected spots couldn't be much better. Hawaii, east trades, 10, 15 knots. As we get into Wednesday, north winds begin to build along the California coast, driven by high pressure at 1032 millibars here. 20 knots, 25 knots by the afternoon. Southeast flow continues for the Hawaiian Islands at, we'll say 10 knots. Okay, Thursday, north winds nuking along California coast north of Point Conception. Southern California protected, though. Not bad. Whatever swell remains, that's the place to be. Hawaii, light trades for the most part. We get into Friday, again, pretty much a north wind event for California, and continuing through the day, light trades for Hawaii. Saturday, finally, high pressure starts pushing into the California coast. Winds lighten up, at least north of Monterey Bay. Trades continue in the 10 to 15 knot range for Hawaii. And then Sunday, more of the same for California. Less winds, that's a good thing. Low pressure in the Gulf of Alaska, sort of cutting out taking the legs out of the high. And Hawaii, east trades, again in the 15 knot range. Can we get to Monday? No, not quite, but you get the general idea. The all-important precip forecast for California. You see the picture. High pressure, 1034 millibars, bulletproof, sitting right over the Great Basin, classic La Nina kind of pattern, blocking everything, driving precipitation to the north. We've been hearing rumors that record rainfalls up in this area of Alaska and maybe northern Canada, of course, driven by the blocking high pressure here and the jet stream just driving everything to the north. We'll put this in motion. We're looking for any sign of blue or snow in the Cascades working its way south. Not so much. We're into Wednesday. Thursday, almost. It makes it to about, not even right to the Oregon state line, nothing. We get into Saturday, rain for, or Friday night, rain for Cape Mendocino, but nothing even down into Tahoe. And then, where are we? We're Sunday. Notice low pressure starting to build here. We know the jet stream is going to start sagging south a little bit. We'll see. Oh, look at this. And rain sinking south, theoretically, a week out, making it to the Bay Area Sunday night a week from now. So we'll see when we do the video if that's really what it's going to be. Again, don't believe a model a week out. And this is extremely weak precipitation at that. So more of a tease than anything at this point. Snow forecast dashboard. Now this goes out 10 days. So 7 days is somewhere around in here. But this at least gives us a hint of maybe some snow for this Sierra. This is at Squaw Valley, but so maybe down into the Tahoe region at best, and likely that will disappear. Snow levels right here. You can see this is the top of Squaw. You got to get into the white before you're at the freezing level. So what are we talking about? 11, 12,000 feet. Today, it's not so bad, 9,000 feet, but for the next couple of days, pretty high. Then it slowly starts working its way down. And theoretically, about a week from now, we're going to start moving into a newer regime, a more favorable regime, and the assumption is that the jet stream is to sort of loosen up the blocking ridge that's just been crushing California, making nice weather, making for reasonable temperatures. Maybe that will break down and we'll get some precip into the state. All right, let's go take a look long term. What's going on with the Madden-Julian Oscillation and, of course, the El Nino Southern Oscillation. El Nino or La Nina. As usual, we're going to start looking at winds on the equator across the Pacific. This is the East Pacific here. This is the West Pacific here. This is the equator. We're interested mainly in the area 5 degrees north and south of the equator in the far West Pacific. We call it the Kelvin wave generation area right here from 135 east, that's the far West Pacific, to about 170 west and then down to the south, right in there. All right, so winds, this is data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino, but they're good for monitoring the MJO as well. Now, these are not real-time winds. These are 5-day average winds. Still, it gives you a pretty good idea. It takes some of the noise out of it, gives you a good idea of what's going on, because both the MJO is a shorter-term trend, but 5 days is, more, not, it's a 30-day trend, okay? And El Nino is a year or two long trend. All right, so winds out of the east over the East Pacific, pretty strong. Look at the length of the arrow. Strong over the middle Atlantic, and then strong over the Kelvin wave generation area. But it's not the actual wind speeds, it's the anomalies. Differences from normal for this time of year. See how strong the winds are in the East Pacific? But for this time of year, that's pretty normal. The arrows here are almost non-existent. When you get to the Central Pacific, though, notice the arrows starting to build from the east. Then you get in the Kelvin wave generation area, and winds are pretty strong out of the east. This is a indicator of the inactive phase of the MJO. Now, the MJO has two phases, active and inactive. The active phase, for those of you that watch these videos all the time, know the drill. It is the active phase when so the MJO moves from west to east around the equator, takes about 30 days to make it across the Pacific. When the active phase moves over the western portion of the Pacific, what it does is it stomps on the trade winds, can actually reverse them, starts imparting energy to the jet stream, which in turn starts feeding the storm track, and also takes warm water that's pulled up here, starts pushing it to the east, not on the surface, but under the equator, down 150 meters. Takes about 2 months for that ball of warm water, they call it a Kelvin wave, to make the whole way across the Pacific. And then it erupts as it impacts Ecuador and starts forming a warm water slick over here in the far East Pacific. If you get multiple active phases of the MJO and they're strong enough, you get multiple Kelvin waves, and that's how you can kick off El Nino. And of course, El Nino is great for swell production. La Nina does the exact opposite, sets up cold water here, stronger than normal easterly trades, just like this, and doesn't do a whole lot for feeding energy to the jet. All right, next up, let's take a look at the wind forecast for the Kelvin wave generation area. Now, this is kind of a strange chart. It's the whole planet on one chart. But you can see the date line, the international date line, runs right up the middle of the chart, right? Okay, the blues are in purples are easterly anomalies. The reds are westerly anomalies. Kelvin wave generation area starts right about here. That's the far west Pacific. Runs to right about here. That's the area we're interested in, because when you get westerly anomalies in this area, that's how you get energy transfer to the jet. All right, but you see, since November, easterly anomalies have been in control of the Kelvin wave generation area, and they're expected to continue pretty much for the whole next week. Okay? So that and westerly anomalies, what we really want in the Pacific, are all locked up in the Indian Ocean. This is kind of symptomatic of not only the inactive phase of the MJO, but of also maybe, well, clearly, La Nina. All right, so digging more, looking for signs of the active phase of the MJO. Outgoing long-wave radiation models. Okay, what are we looking at? Well, right here. This is, again, the Pacific Ocean. There's South America, Central America, Hawaii. Equator runs right along there. Australia, New Guinea. Kelvin wave generation area, the important West Pacific region right there. The blues are... This is outgoing, where is it, right? Outgoing long-wave radiation. Fancy words for cloud cover, right? Okay, so blues are negative anomalies, meaning more cloud cover. Yellows, less cloud cover. Consider this the inactive phase of the MJO. Consider this the active phase. This is the one we want. We want it to be right there. Okay, but today it's not. It's trying to move into the Kelvin wave generation area. Inactive phase trying to move out. 5 days from now, this per the statistic model, the active phase makes marginal progress, even 2 weeks out, 15 days, but pretty weak. No clear signs of, significant support for storm development. The GEFS model, there we go, pretty much painting the same picture. So the two models are in agreement. So we'll dig a little deeper. What are these charts? Phase diagram charts. One's the statistic model, one's the dynamic model. What are we looking at? See that circle right there? Assume that is the North Pole, and we're looking down on the North Pole, the top of our planet, and the equator's out around the edges there, out around here. The MJO moves from west to east, from the Indian Ocean over the maritime continent, West Pacific, East Pacific, underneath the United States, across the Atlantic, over North Africa, back to the Indian Ocean. The dot here is where the active phase of the MJO is. The further away from the circle it is, the stronger it is. So a very weak active MJO at the moment, and forecast to move into the West Pacific, but get even weaker 15 days from now. The dynamic model suggesting pretty much the same thing, only the active phase not even moving to the West Pacific, just stalled over the maritime continent. The 40-day upper level model, okay? So there is South America, Central America, the equator right there. New Guinea there. Date lines roughly right around there. Australia, you get it. Yellows are areas not favorable for precipitation. Dry air. Greens, favorable for precipitation. This runs about a week ahead of what goes on at the surface. So we could roughly say active phase of the MJO, or at least something like it. In the East Pacific, moving into Central America, December 16th. Inactive phase of the MJO, continuing over the Pacific into about January 10th, and then perhaps a weak active phase following after that into at least mid-January. That's a little bit different than what all the other models are suggesting. All right, then the CFS model. This is a 1 month forecast, all right? Whole planet on one chart. There's the date line right there. Kelvin wave generation area. West end starts right about there. East end right about there. So this is the area right in here we're interested in. You can see past performance here. The blues are easterly anomalies. The solid contour is the active phase of the MJO. So this was back in October. In November, we had a strong inactive phase of the MJO. Notice all the dark blues in here. Strong easterly anomalies. Even with that, we've gotten 2 storms. Not bad. Okay? As we move forward, we see literally no sign of the inactive or active phase of the MJO, and we see blues continuing easterly anomalies. So no sign of the MJO, but what we do have is this dashed purple line, and you go up here, it says low pass filter. That's effectively telling us there's a high pressure bias set up in the Pacific, locking down the Kelvin wave generation area. And what that really is La Nina. And you see the solid contour over here in the Indian Ocean with your active phase, but nothing can penetrate this high in terms of the active phase, and it just has everything locked down at the moment. All right, and then we have the 3-month CFS model. Past performance is down here, the forecast is here. Kelvin wave generation area from about here over to about here. So it's this area right in here that we're interested. The blues are easterly anomalies. Clearly you can see strong easterly anomalies forecast into Christmas, then building even stronger in January, but not completely filling the Kelvin wave generation area because there's westerly anomalies supposedly forecast building in the mid-January, February time frame. Let's overlay the MJO, see what we got here. There we go. All right, so the dotted contour is the inactive phase of the MJO. We know that is in control of the Kelvin wave generation area right now. Even with that, even with La Nina, we have storms occurring. That is a good sign. Remember, the MJO does not completely dictate everything. It is an influencer. That just because you have the inactive phase of the MJO, just because you have La Nina, doesn't mean you're going to not have storms. Clearly, we're having them. Clearly, they're happening. There's some latent heat energy built up in the atmosphere because you don't get seas of 54 feet just out of the blue on a whim. There's got to be some reservoir of energy somewhere driving all that. All right, so anyway, inactive phase of the MJO, moving out of the Kelvin wave generation area right around before Christmas. Active phase of the MJO starts moving in about December 22nd. So previous runs have had this whole thing connected in one big ball. So the model, kind of doesn't quite have a complete handle on it, but active phase from, we'll say, December 22nd the whole way into, what is that, late February? That'd be a pretty good long run. There is a bit of strong easterly anomalies, but there's also some westerly anomalies forecast. And after that, the inactive phase of the MJO. Overlay the low pass filter. Again, the same deal. The dotted contour, high pressure in control, 2 contours, building to 3, maybe even 4 as we get into late January. The model sort of fluctuates on this, and this seems to be one of these more active runs. The low pressure bias is over the Indian Ocean right here, building to 2 contours around Christmas time, holding for a month or so, and then fading out. The border between the two, not really moving. Yesterday we saw one that actually had the inactive phase sort of moving almost out of the Kelvin wave generation area, but today it has snapped back, and most of the runs are pretty much similar to this one. All right, enough MJO talk. Let's go talk La Nina, El Nino. What's going on in the ocean? All right, again, data from the TAO buoy array. The buoys strung across the equator, used for monitoring El Nino. West Pacific here, East Pacific here. These are the anchor lines on the buoys. The X's are sensors that are on the buoy, on those anchor lines. They are temperature sensors. You take the data from all these sensors, run it through a model, it fills in the gaps, and you get a profile of the subsurface. This is down 100 meters, down 200 meters, so like 600 feet down in the ocean, of the temperature balance. Warm water, the 29 degree isotherm there is the centigrade, 28 degree isotherm at 170 east. I think it was more like over here, like 175 last week, so it sort of backtracked some. That said, the 24 degree isotherm has been locked at around 140, 135. It's making a little incursion off to the east to 120, but you see, in general, cooler water still in control of the East Pacific. That's the hallmark of La Nina. In fact, let's look at anomalies, differences from normal for this time of year. Now, there's a little bit of encouragement here in that we're showing 2 degrees above normal temperatures in the West Pacific. They were getting no further than 160 west, which is right there. Maybe a little finger to 150 almost, but that's not significant movement. Cooler temperatures, 1 to 2 degrees, that's 2 degrees centigrade, that's about, what, 3.5 degrees Fahrenheit below normal. Cool water in control of the entire East Pacific, even to a point south of Hawaii and then some, past the date line. So still, this is the typical La Nina pattern, right? You get stronger than normal east trades, they create upwelling, you get this cool water pattern, you get no Kelvin waves. Remember, we were talking about active phase pushing over the Kelvin wave generation here, creating west anomalies pushing from the west to the east. That would take this warm water normally and it would start pushing it up into here. But with stronger than normal trades driven by La Nina, you get none of that. Cold water in control, and wherever there's cold water, you don't get evaporation. Where you don't get evaporation, you don't get storms, you don't get heat transfer into the atmosphere, and it kind of locks things down. You end up with high pressure normally. Another model using the same data, painting the same picture. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 5 degree below normal centigrade temperatures here in the far East Pacific, and going the whole way past the date line. The date line's right here, into about as far, basically the entire equatorial Pacific full of cool water. Historically, this is about the time of the year when La Nina peaks. Keep that in your mind. Sea surface height analysis. Okay, this is from Jason 3 satellites. Strip out the waves, strip out the wind waves, strip out the tides. Just trying to measure the spheroid surface of the Earth, the ocean, and is it higher than or lower than normal? You can see right here, 15 centimeters below normal. This is South America, Peru. Ecuador right there. That's the Galapagos. Peru's down here. Chile further south. You just get the sense there's this big glob of colder or lower than water, lower than normal sea surface height. What's that mean? Well, cold water contracts. When it contracts, it creates a divot on the ocean surface. So all this is doing is telling us, yeah, there's a lot of cold water filling up this whole area. We know high pressure is circulating here, down here, driving strong east trades, creating upwelling, creating colder than normal temperatures. This is confirming that. Sort of a historical look here. This is the West Pacific here, East Pacific here. Oranges, reds, yellows are above normal temperatures. Our last Kelvin wave, January, February of this year, almost a year ago, made it across the Pacific into Ecuador in about the April time frame. Quickly faded out. Cooler than normal temperatures set up as trade started building. The global circulation, the way we want it to be, collapsed. We have, again, east trades in control. This is sea surface temperatures maxed on, looks like about October, right around Halloween in terms of the maximum coolness. This is upper ocean, the upper 300 meters of the ocean. So this is kind of interesting. Keep this in mind. We think the peak of this La Nina was really here right before we got into November. Here's just another view of that same thing. It's just showing upper ocean heat anomalies from the date line to a point almost to Ecuador. You can see we had warmer than normal temperatures into about April, and then April temperatures crashed. They warmed up for a second. They got as cold as they possibly could right before November, and then have since sort of plateaued off. Next up, sea surface temperatures. So there's some interesting things to see here. At first blush, you just look and go, well, gosh, there's lots of cold water. Here's Chile, here's Peru, here's the Galapagos. Cold water just filling this entire area. Yes, it is, absolutely. But you know what? This water was a lot colder about a month ago here. And all this area here, these little eddies of extreme coldness, are much warmer than they were even 2 weeks ago. I mean, it sort of gives you this sense that, yes, La Nina is fully in control, but maybe it's losing some of its edge. Maybe it's already maxed out. The next piece of data is the sea surface temperature trend. Differences from normal for this time of year. And, well, that's not true. Just the change in temperature over the past 7 days. And you see here the yellows, orange, reds, temperatures warming significantly along Peru, Ecuador, along right in the critical area of the Galapagos, the whole way out to a point south of California. All right. And the interesting part is there's no active phase of the MJO going on right now. It's the inactive phase for sure, and La Nina in control, but temperatures are warming. Our theory at the moment is because the temperatures have warmed, even though it's not much, and it's only a short-term trend, that the atmosphere maybe senses some of that and sees a little opening, and because there is latent heat energy, it's got the opportunity to produce some storms. It could be something else. It could be completely unrelated to this. It could be equatorial Rossby wave related. It could be a bunch of things. But it seems like, if nothing else, the peak of La Nina has probably happened. We don't see any major push in the immediate future that's going to drive temperatures any colder. And if that's the case, that sort of takes the foot off the brakes for a little bit, if you will. And sometimes when you're on these extremes, extreme El Nino, extreme La Nina, and just a little change, in a favorable direction can unleash a chain of events that gets you storms, sort of like what's happening right now. And then again, looking at the big broad view, clear La Nina, what do you want to call it? A dagger into the heart of the Pacific Ocean, cold water in control. Wherever there's cold water, high pressure, typically north and south of that. But we do know the jet, because it's been held off, because the storm track's been held off so long in the Pacific, again, we've said that, La Nina doesn't mean you won't have storms. It just means that the probability of them are less. So the point being, when you do get a storm, when you do get activity, make the best of it. And this is clearly one of those little windows right now. We don't expect this storm pattern to continue for very long. We could be wrong, but odds are not in that favor. So make the most of what we have right now. Sea surface trend history in the Niño 1.2 region. This is the area right there along Ecuador and Peru and the Galapagos. Temperatures have been slowly working their way up today. This is the differences from normal. 0.815 below normal. There's normal. So still clearly a La Nina trend. But again, we're talking about a little removing your foot off the brake, a little push in the right direction. Maybe so. The Niño 3.4 index, the official El Nino monitoring region, minus 1.2 degrees right there. Dead steady, but look at that. It bottomed out at, minus 1.65 in early November. It's been holding, sort of warmed up and holding since. All right, so what does the atmosphere think is going on, right? Southern Oscillation Index, difference in pressure between Darwin and Tahiti. When the pressure is lower at Tahiti, the index goes negative. If it stays negative for a long period of time, let's say 10, 15 days, then maybe that's a sign of the active phase of the MJO. If it stays positive or negative for 30 days or more, 90 days, then maybe that's a sign of La Nina or El Nino. All right, today's contribution, positive, 11.78, and just scanning down the list here for the past month. Nary barely a negative to be found, suggestive of at a minimum, the inactive phase of the MJO. 30-day average takes the noise out of the numbers, 9.74, positive 9.74, and you see we went from 3.17 to 9.7 in a month. So clearly a La Nina pattern indicated. The 90-day average, though, maybe this is more just the inactive phase of the MJO. That's what the 30-day average is really all about. The 90-day average is our El Nino La Nina indicator. Positive again, 7.7. And what has it been doing? Wow, look at that, 7.67 a month ago. If we were moving into a stronger La Nina pattern, this should be continuing to rise, but it's stalled, completely stalled. Sea surface temperatures are stalled, or if anything, backtracking, suggestive that maybe, just maybe, we're already at the peak of La Nina. That'd be too much to ask for, but it would be maybe a hope. The 30-day moving SOI graphed out for the past, 2 years or so. You can see back in 2018, we were in the positive range, La Nina territory. The downward pushes are the active phase of the MJO. The upward pushes are the positive phases of the MJO. Then we went into 2019. We almost go, God, we're like in a weak El Nino. And then here we are in 2020. You can see just a steady upward rise. Now here we are. If this is our peak, we're actually at 9. So these are two different indexes. They calculate a little bit different. But the interesting part is, if this doesn't go any higher, and if anything it starts falling, that would maybe be some indication that we are in fact at the peak of our La Nina. And then finally, the official El Nino 3.4 sea surface temperature anomaly forecast. So this is where things get even more interesting. Today, temperatures, I think we said 1.2 degrees. That's what we saw off the one index. The model is saying the same thing. And now previously, I mean, not even that long ago, it suggested temperatures were going to get down to -2. And at one point, it even said -2.5. Now, it's suggesting, well, maybe down to 1.3 degrees. But given everything we're seeing, maybe we're not going to go any different than where we are now at 1.2. So this is the key data point to be watching over the coming weeks is, do the temperatures go any lower? Is there cooling? Are east anomalies still just railing, or has the peak of La Nina been reached? If that's so, if we're in the 1.2 degree range, that's not a horrible La Nina. It's like, yeah, okay, standard correction, these things happen, but it's not the end of the world. And the model suggests by July we'll be at the -2. Actually, 2 days ago, the model said we'd be dead neutral. So this is still kind of voodoo territory. We don't know where we're really going. But in general, things are looking up. All right. So the good news is storm number 2 is in the water. Confirmed sea heights in the, 54-foot range. Swell is in the water. Bits of it already hitting Hawaii. The rest of it pushing mainly towards the U.S. West Coast. Large surf is expected. Quite large. If you're not experienced in big surf, don't even think about it. Just go, give the day a break, let it go, leave it for the pros. All right, that said, beyond that, the models are hinting at more moderate-sized surf. The storm machine is not to shut down, and maybe we could have even another significant class swell result with a bit of luck. This is a reach, but we're hoping, right? Gotta have hope. The better news is, precipitation-wise, no precipitation obvious for California, but maybe a week out. Hope is looking up. Longer term, peak La Nina. Have we reached it? Possibly. Typically, peak El Nino is right around the Christmas time frame, but the peak La Nina is normally a little bit early December, late Thanksgiving time frame, something like that. So it's not out of the range historically that we're already there. And if it's only at -1.2 degrees sea surface temperatures, that's not bad. That means we'll get out of this, we're going to get hurt a little bit, but not horrendous. And right now, there is storms, there is surf, so, hey, you can't be too upset about it, right? Make the most of it. All right, so that's, and long-term beyond that, well, we don't really know. We're hoping this is a one-year La Nina event. Our guess is it's going to, even if this thing, all resolves itself by next summer, it's still going to be the late in next fall till the global atmospheric circulation gets to a point where we're back in a normal pattern. All right, so that's it right now. If you enjoyed the video, give us a thumbs up. We'd appreciate it. Comments, always welcome. We try to reply to all of them. If you have any questions, you don't understand something, please drop us a line. We'll do our best to try to explain it to you or give you links to charts. And you can follow along. All the data that we present here is available on Stormsurf.com. You can follow along during the week, then test your knowledge with the video at the end of the week. We typically do these on Sundays. So if you haven't subscribed, please subscribe. That way you'll get an automatic notification when we post these videos. But if you don't like that, just go to Stormsurf.com. Again, we post a link at the top of every page of the site after we post the video, and then you can get to it that way. All right, things potentially looking a little bit better. And that's making us happy. All right, enjoy it. Go get some surf. Be safe. We'll see you next week. Same time, same channel. Thanks for watching.